Myself Nitin Kumar, Assistant Professor NIFTEM, welcomes you all in a training module on cold chain logistics funded by WIZ Germany and jointly organized by CII and NIFTEM Kundli. In today's module, we will discuss the calculations for a cooling load and that will be utilized for the design of cold storage. A cold room is used to slow down the deteriorations of products such as horticulture produce, vegetables and meat and keep it fresh as long as possible. Heat is a factor that accelerates the product deteriorations. For this reason, the heat in the atmosphere of a cold room has to be removed and the product will be cooled down. To remove heat from the environment and to perform an appropriate cooling process, it is necessary to calculate the cooling load, and that is very much essential for the design and selections of a components of VCRS system like compressor, capacity, evaporator, expansion valve and condenser. Cooling load varies according to the type of product stored, time period for which the product is stored and storage temperature. As far as cooling load concerned, it includes sensible heat, that is the product load, respiration load, transmission load, internal load, the heat generated from fan, bulbs, human beings, lighting, etc., then heat load due to the air infiltrations and latent heat of fusion. Sensible heat is the amount of heat to be removed from the product to lower the temperature of a product from its initial temperature to the storage temperature is called sensible heat. It is calculated with the help of equation that is Q equal to mCp delta T, where Q is the product load or sensible heat, M is the amount or mass of a product to be stored into the cold storage, then Cp is the specific heat of a product, kilojoule, kilogram per Kelvin, delta T is the temperature difference. Respiration load. Fresh fruits and vegetables are live products and they continue to respire at varying rate for days and even weeks after harvesting. Respiration is a chemical process by which fruits and vegetables convert sugar and oxygen into carbon dioxide, water and heat. I mention a chemical equations here, that is C6H12O6 plus O2 is converted into carbon dioxide, water, and this much amount of energy is generated. Transmission load is heat added to cold storage through floors, walls and roof due to the temperature difference across the surface. Heat always flows from hot to cold region and the interior of a cold room is obviously colder than the surrounding. So heat is always trying to enter the space. One can calculate the transmission load with this equation Q2 equal to UA delta T, where Q2 is the transmission load with a unit kilowatt, U is the overall heat transfer coefficient, A is the area through heat added from outside environment and delta T is the temperature difference between cold storage inside and outside. Fourth load is internal load, which is the heat generated by people, light, electrical motor and other heat dissipating equipment in the refrigerated space constituting the internal load of a refrigeration system. The heat generated by people can be calculated number of person multiplied by heat produced multiplied by the time of stay in the cold house. The heat produced by the light can be calculated with the multiplications of number of lamp, then rating per bulb as well as the time of operations. Simultaneously for fan as well as other electric motors or equipment, and that at the last we can sum the heat load generated by these factors. Heat load due to the air infiltrations. Due to the opening of door, volume of air change happens and entering of new outside air has heat respective to outside temperature that has to be considered in the calculation of total heat load. It depends on inside and outside temperature, number of times the door open and the energy content of air. Heat load due to infiltrations is calculated with the situations, number of times the change in volume of air multiplied by energy added per unit volume with a temperature difference. Latent heat of reason can be defined as the amount of heat required to change the state of matter, that is from liquid to gas. Latent heat can be latent heat of vaporization or latent heat of fusion. Latent heat of vaporization मतलब liquid to vapor, latent heat of fusion मतलब liquid to ice. Latent heat of fusion is used in freezing and defined as the amount of heat removed from product to change the state of matter from liquid to solid ice. The latent heat of a product is Q equal to m into lambda, where m is the mass of product, lambda is the latent heat of fusion of a product. In case of water, the latent heat is approximately 334 kJ per kilogram. Total cooling load. The load is the sum of a product load, respiration load, transmission load, internal load, and infiltration load. In case of freezing process is a part of cold storage, then the latent heat of fusion has to be added into the total load, and the total load becomes a sum of product load, respiration load, transmission load, internal load, infiltration load, latent heat of fusion. Let's discuss the design applications with a problem in which cold storage with a dimension 6 meter length, 5 meter width and 4 meter height. We need to store 1000 kg of apple at 4 degrees centigrade with a 24 hours, where the respiration rate of apple is given 745 kilocalories per ton for 24 hours. In addition to this, 3 people are working for 4 hours in cold room and heat of respiration of person is 170 kilocalorie per hour. There are 3 lamps, each having 120 watts, and they operate for 4 hours per day. In addition, there are 3 fans, each 300 watts and operate for 16 hours. The temperature and humidity of ambient air is given 30 degrees centigrade and 50% respectively. The temperature of ground is 24 degrees centigrade, which is cooler than the ambient air. Polyurethane material is used for insulating the wall, roof and floor, which has overall heat transfer coefficient, that is capital U, 0.28 watt per meter square Kelvin. Due to the opening of door, about 5 volume air change per day. Volume calculated at 120 meter. Each cubic meter of new air adds the heat about 2 kilojoule per degree centigrade. Inside air is 4 degrees centigrade and outside temperature is 30 degrees centigrade. Based on the given data, we can calculate the total load requirement for this particular situations. So first we will calculate the product load with an equation of T equal to mCp delta T. You can see in this slide the calculations done, and the value of product load comes as 1095 watts. In addition to the product load, the next load is respiration load generated from the apple, and which will be calculated with these equations. Q are equal to quantity of apple in ton multiplied by the heat of respiration in kilocalorie per tons, and you will be getting the value as 12.79 watt. Watt is joule per second. The third load, that is transmission load, in which we do have different components. The first component is heat gained through wall. So we need to find out the area of wall, and then with the equation of Q equal to UA delta T, one can easily calculate the value of heat gained through walls. In this situation it is 640.64 watt. Similarly, heat gained through roof can also be calculated, and the figure comes 218.4 watt. In addition to roof and wall, the heat gained through floor has to be calculated with the same equation, and the values comes as 168 watt. So the total transmission load is the sum of all these three loads, and which is coming as 1027.04 watt. Next load is internal load, and that is generated because of the person who is working inside the cold storage. Although they will be stay for small durations, but they do generate some amount of heat, and which will be calculated with the help of these equations, where N stands for number of person and heat produced in kilocalorie per person per hour multiplied by time of working. In this very particular situations, the amount comes as 35 watt. As per the data given, we do have lights as well as a fan inside the cold room, and this will generate some amount of heat, and that will be calculated with these equations of the number of lamps multiplied by rating of lamp as well as the time of operations. So the data coming for the light is 60 watt and for fan is 600 watt. So one can calculate the total cooling load with the addition of people load, lighting load and fan load, which is coming as 695 watt. Next is heat load due to the air infiltrations, that is because of opening of the door of a cold storage even for shorter durations, and this can be calculated with the number of times change in the volume of air multiplied by energy added per unit volume and the difference in temperature. In these situations, this value comes as 360 watt. So total cooling load can be calculated with the addition of product load, respiration load, transmission load, internal load, heat load due to the infiltrations, and if we add together, the final figure is 3.189 kilowatt. So this is the amount of energy which has to be extracted from the refrigerator space or cold room to maintain the product at that temperature for 24 hours. In this module, we have discussed a design parameters as well as a design calculations based on the different factors or different loads, along with examples of Apple storage. I hope you will able to calculate the design parameters based on the requirement. Also, you can cross check with the design data based on the understanding. Thank you.